Hello, and welcome to this installment of the Future Driven Forum series. My name is Mike Hernandez. I'm the Senior Director of Safety here at the Alliance for Automotive Innovation. And today, we're going to bring you a panel of really smart people to talk about the issue of distracted driving. We're going to focus on in-vehicle technologies and the advancements that have been made in the past decade or so, and how we can leverage those technologies to mitigate distraction. So I will first just introduce our panelists. We have with us today Dr. Kevin Liu. Kevin is the Senior Director and Head of Harman Ready Care Product Group. He has more than 2 decades of experience in engineering, product portfolio management, and technical sales focusing on ADAS sensors and systems for global Tier 1 and automotive tech companies. Prior to Harman, he was the Vice President of the Smart Sensor Business Unit and General Manager of U.S. Operations at Zhongmu Technology, a startup provider of autonomous driving systems. Before that, he was Chief Engineer at Magna Electronics, focused on the development of their ADAS products, and he earned an Automotive News PACE Award in 2018. Kevin is a prolific inventor with more than 100 patents in the areas of ADAS, computer vision, and cameras. He holds a PhD in physics and a master's degree in electrical and computer engineering from Wayne State University, as well as a bachelor's degree in physics from Nanjing University in China. Kevin, thank you for joining us today.
Oh, thank you, Mike. Hello, everyone. I'm really glad to join this panel discussion regarding a very, very important topic, how to prevent distracted driving. So I'm really glad and happy to participate in this discussion. Thank you.
Thanks, Kevin. Next up, we have Dr. Alex Noble. Alex is the Senior User Interface Safety Lead at Cariad Inc., where she works to develop research-based user interface guidelines. She joined Cariad after working at Battelle, where she managed and provided technical leadership for federal transportation projects. Alex has diverse experience in driver behavior research, human-machine interaction, and driving automation systems. She earned her PhD from the Grado Department of Industrial and Systems Engineering at Virginia Tech, go VT, in 2020. Welcome, Alex.
Thanks, Mike. I'm glad to be here.
Next, we have Dr. Stacy Balk, who joined the National Highway Traffic Safety Administration as the Division Chief for Human Factors and Engineering Integration within the Office of Vehicle Crash Avoidance and Electronic Controls in 2019. She leads a team focused on the application of human capabilities and limitations to the vehicle design of vehicles. Her work spans a breadth of topic areas ranging from vehicle automation and accessible design to driver distraction detection and mitigation. Stacy earned her PhD from Clemson University and her BS from the University of Iowa. Stacy, thank you for being here.
Thanks for inviting me. I'm excited to talk about this very important topic, both to me and to NHTSA as a whole. Looking forward to it.
Thanks, Stacy. And finally, Vishnu Sundaram is the Senior Vice President and Chief Technical Officer at Gentherm. He is responsible for leading Gentherm's technology strategy, advanced product engineering, longer-term R&D, and the company's partnerships on innovation in climate and comfort, pneumatic lumbar and massage, battery performance solutions, electronics and software systems, and patient thermal solutions. Vishnu was previously the Senior Vice President, Head of Cockpit Connected Services at Stellantis, and prior to Stellantis was the Senior Vice President of Telematics for Harman Samsung. He began his career at Intel and later moved to Trilogy, where he was Technical Fellow in Predictive Analytics and Machine Learning projects. He has extensive entrepreneurial and startup experience, where he was the co-founder of LifeBlob and founded Interchain. Vishnu holds a master's degree in software engineering from PSG College of Technology and has completed the Executive General Management program with the Wharton School of the University of Pennsylvania. He is also the lead and co-inventor of 6 patents and was named a Rising Star in 2018 by Automotive News. Thank you for joining us today, Vishnu.
Excellent, Mike. Really looking forward to the discussion here. This topic is close to our heart. It's not only about detection, but also how do we help drivers commute safely. So looking forward to a very good discussion here.
Yeah, thank you, Vishnu, and thank you to all the panelists today. I'm very excited to have you here. So let's just jump right into it. The issue of driver distraction is a big one. We have reports that NHTSA puts out regarding the annual issue of distraction, amongst many other things. We have over 3,000 fatalities each year that are police reported. Now, what is interesting to me is that in February of this year, NHTSA also published a report looking at naturalistic data. And essentially, that's a camera inside the vehicle that just monitors the driver, not a driver monitoring camera per se, but when issues occur, it gives researchers the opportunity to see what was happening with the driver at the time. And that report indicated that in about 29% of the crashes, distraction was a factor. And so what that means is that this 3,000 fatalities a year that we attribute to distraction is a gross underestimate. In fact, having almost a third of fatalities, which, by the way, is over 40,000 a year on current trends, that means that we have more than 10,000 lives a year lost to driver distraction. This is just a huge loss of life, and it is completely preventable. So what we're hoping to do today is to talk about where we've come and where we're going with regards to distraction. So let me just start by giving a little bit of background on what the issue's been from the policy side, and then we can jump into some questions for our panelists. So in 2006, the auto industry got together and put a guidelines together for driver distraction. This was intended to give automakers guidance on how to develop their vehicles, the user interface of their vehicles, to minimize driver distraction. And it focused on visual manual distraction. In 2013, NHTSA actually published another set of guidelines that was more comprehensive and went a little bit further. But it's been over 10 years now since we saw the last set of guidelines. And as you can imagine, technology progresses at an incredible rate. And in those 10 years, we've seen a lot of technologies come out that have the capability of addressing distraction in a much more comprehensive way, I think, than what we've seen in just the visual manual field. So with that, I'd like to ask the first question. What are these technologies? What in-vehicle technologies do we have currently available that are either in deployment or potentially in development that can help mitigate driver distraction? And so I will turn it first over to Alex, who is, of course, in the industry itself. So Alex, why don't you take this first question?
Sure, happy to. So currently, a lot of manufacturers use lockouts to prohibit the use of specific applications or features on the center display while the vehicle is in motion. A lot of these decisions are based on the 2006 and 2013 guidelines that you mentioned. Unfortunately, we've seen over the years that some of these functional lockouts have unintended consequences, where drivers are turning to their cell phones to complete the tasks that aren't available on that center display. The Volkswagen brand has implemented a feature called dynamic function blocking, or DFB. And with DFB, some of those features that were completely locked out may be fully or partially accessible, but only for a short period of time while the vehicle is in motion. So the key difference between dynamic function blocking and the current functional lockouts are that users are allowed to complete some of these tasks, but their ability to interact with the screen is periodically paused to encourage them to turn their attention back to the forward roadway. And really the goal of dynamic function blocking is to encourage the responsible use of these in-vehicle systems that drivers do need or want to complete while they're driving. Also minimizing the distraction potential of our displays that we've put in the vehicles, and most importantly, minimizing the likelihood of drivers turning to their phones to complete these blocked activities. And what's really cool about dynamic function blocking is its ability to scale across a spectrum of all of the Volkswagen Group vehicles. The current implementation of dynamic function blocking uses a simple taps mechanism to assess whether the drivers are using the screen and consequently when they should be paused. But in the future, we do expect to leverage multiple sensors, including the vehicle kinematics, ADAS sensors, and other active safety systems to determine if drivers are paying sufficient attention to the roadway based on their driving performance.
Thank you, Alex. And also we have, from a supplier perspective, Kevin, I'd be interested in getting your take on that as well. Kevin, you are on mute.
Thank you, Alex, for your perspective from the OEM, OEM angle. From the supplier perspective, we have been looking into a technology called eyes on road. Basically, it's a distraction and the drowsiness detection, and this is being starting to be implemented in the vehicle, especially in Europe, based on Euro NCAP and the GSR requirement. But in terms of the newer technology, looking down the road, is this eyes on road enough for preventing, detecting the distraction, the drowsiness, and preventing the distraction, the stress, and other aspect of the distracted drive? We believe, Harman International believes, we need to tackle mind on road. Other than eyes on the road, if you are driving, looking forward, looking ahead, but your mind is actually in somewhere else, and this is a current technology cannot detect, right? So Harman is working on, based on the neuroscience and neurophysiology standpoint, on top of the normal camera-based or the radar-based vital detection, to make sure mind on the road. If mind is not on the road, we will our technology will give a alert or something that the OEM's vehicle will be used to nudge or bring the mind back, let's say, to avoid the distraction. Some other technology, in the other end of the spectrum, for instance, how do we declutter the information in front of the driver, as Alex said, right? Some ideas of adapt to the driver's gaze, right? If the driver is looking at a certain center console, right? But center console becomes bigger and bigger in the screen-wise, and we can determine what actually user or the driver is looking at, but turn off the other informations in the driver's peripheral vision, for instance, things like that, to simplify and declutter what's in front of the driver. So those are the few technologies that the industry is working on.
Thank you, Kevin. And I think we'd also benefit to hear from Vishnu's perspective as well on this. Vishnu, do you have anything to add?
Absolutely. Thank you, Kevin and Alex. I love the mind on the road terminology that you used. So we are all looking at bringing best solutions through our presence inside the car. And we are solving for this driver distraction detection from a point of view of Gentherm, where Gentherm is present in several physical touch points. So our technologies are on the seats, are on the steering wheel, are on the armrests and all of that. So what we are doing is, without adding more hardware, we are coming with a concept called virtual sensors. So basically, we use existing touch points that drivers and passengers have in the car to detect the attention. So the correlation of your physical conductivity, your skin temperature, all of that, and correlating it to attention is how we are addressing this challenge. We often use a combination of sign, sensation, and software, a combination of all of these three. So that's one part of what we focus on. The other interesting part that we focus on is intervention. Now think about driver distraction. I mean, detecting driver distraction is one thing. Showing a coffee mug in the front of him doesn't do much. Yeah, I know I'm drowsy and I need a coffee, but it's I don't have a coffee mug ready to pull out and drink. I need to survive until I reach the coffee shop. So that's where we are focusing on intervention. So we are working on software-defined experiences. So these experiences have the ability to restore attention through a thermophysiological articulation by using heat, cooling, and all of that, which can keep you awake for 30 more minutes at least and help you reach the coffee spot. So that's how we are looking at it.
Yeah, Vishnu, that's very interesting, and I'm very interested in the touch point sensors that you mentioned, and especially your reference to skin temperature. I know that biometrics is playing a part in a lot of these responses. Can you elaborate a little bit more on what the role of biometrics might play in distraction, and also maybe touch on the accuracy of some of these systems?
Absolutely. So we have a research team, and the team has conducted a lot of clinical trials. And what these clinical trials show is there is a strong correlation between aspects like skin temperature, conductivity, sweat, and muscle tension, and all of that. What we are specializing or what we are doing is, without adding new hardware, how can we detect these parameters? For example, can we detect the muscle tension based on how you are holding the steering wheel? And then we have virtual sensors which can estimate your body temperature without physically adding another sensor. It's an estimation, but it's reasonably accurate. And to your question, one of these directly correlate to attention? No, but a combination of these have a high degree of correlation to the attention. So we use EEGs to measure this in control conditions, and we see a huge possibility to use these virtual sensors for detecting attention.
Thank you, Vishnu. Let me kick it back to Kevin. Kevin, does Harman utilize biometrics in its systems, and how, maybe along the same lines, how can that be used to assess distraction?
Right. So we do use the biometric information like facial features, eye gazing, eyelid open and close, as well as the vital signals like heartbeat signal, heart rate, heart rate variability, and also breathing. Right. Those are all the biometric informations we are using to assess the mental load, the stress, the whether it's a distracted in the mind, whether are you passive distracted or active distracted. So we not only look at those biometric sensors, we have actually in-house team specialist with a degree in psychology, psychophysiology and neuroscience and the behavior science that study all those the contribution from the distracted mental load and effect to the distracted driving. Not only distraction, also stress, right, and the mental load. This is a very wide range of the sensor biometric information we are trying to put together and utilize them. Of course, what Vishnu mentioned, they are also very good biometric signals that can be used.
Great, thank you. This is incredibly interesting. I would like to maybe continue this thread a little bit and talk about when we talk about this technology being implemented into the vehicle. I'm interested to hear how the technology uses a threshold to determine when to issue. I know Vishnu mentioned the coffee cup, but that's usually, I think, maybe more time-based, may have some input from like steering sensors and so forth, but it's very generic. When we talk about maybe some more of these precisely estimated systems, where do we draw that line between what is a safe level of distraction versus a unsafe level of distraction, and where do we put in that alert to the driver? So maybe I'll start with Stacy, if you want to kick this one off.
Yeah, absolutely. I mean, we have a lot of background foundational research that really attributes eyes off road time to crash risk. We know there's kind of this magic number around 2 seconds of eyes off road time that is correlated highly with the likelihood of getting into a crash. You know, we've used those data for our guidelines that are now aging. But now, as you mentioned, with these new technologies, with the potential of really understanding more how people are interacting with a vehicle, not just the native interface through touches and things like that, but also through bringing in external devices into the vehicle. It's no secret that people are using their phones in the car, right? So things like camera-based driver monitoring systems now really do have the capability of looking at the driver and seeing what they're doing and interacting with that. And so to that end, we really see this new opportunity of leveraging those technologies that are already making their way into vehicles for systems like level 2 automation and applying them into other contexts. So we recently actually just kicked off a study looking at this exact topic. So we're really looking at the ability for some of these newer driver monitoring systems to look at your eye gaze on and off road and how that tracks over time. The driving environment is really challenging and dynamic, as we all know. We've got light fluctuations. You know, your head doesn't stay in the same bounding box and you're not on a bite bar like you are with the research equipment. So really, can these systems work dynamically over time? And what is the accuracy of understanding where people are looking on and off road? And then beyond that, how do we integrate that with alerts and timings on the road? So if we know 2 seconds is the magic number, that's wonderful.
We had a little bit of a freeze, so I think. Oh, Stacy, are you still with us? Okay, while Stacy is trying to get her system back online, let's go to Alex on this one. I'm interested if Alex, you have some thoughts in addition to what Stacy mentioned, and maybe even beyond what might be available from the DMS or the cameras specifically.
Yeah, absolutely. So in addition to all of the great things that Stacy's mentioned, we're definitely leaning on that past great data and research to continue moving forward. As part of my role at Cariad, I have the unique privilege of working with the AHEAD Consortium, which is a pre-competitive academic industry collaboration that's comprised of MIT, Touchstone Evaluations, Google, Honda, the Volkswagen Group of America, and JLR. A lot of these folks that are participating were also very heavily involved in the initial distraction guidelines. So it's really cool to work with them. And one of our primary motivations as AHEAD is to consider the functional approach of driver attention, which, as Stacy was mentioning, this requires a system-wide overview of the net safety impacts of all of the sources of demand, the primary driving task, the secondary driving task, or secondary non-driving tasks, under all levels of automation, and the role of the operating context to really understand the impacts of all these things on driving safely. So really, instead of considering what an appropriate threshold is of distraction, because that can vary dramatically depending on your driving context, your skill, and a number of other things, we're focused on ensuring the driver's attention to the road is more than sufficient to meet or exceed the demands of the driving task. So having attention thresholds that are context dependent. So for example, if the driver's driving in an environment that requires additional attention, such as poor weather, or you're in some stop and go traffic with really high speed variability, or perhaps you're driving in an area where you have a larger volume of pedestrians and other vulnerable road users, your attention threshold really needs to shift. So the amount of time we would allow somebody to operate that center stack display will be much lower than, say, in a clear weather, free flow traffic on a freeway with wide lanes. So that's really kind of where we're looking at this. It's not necessarily a appropriate threshold for distraction, but rather the appropriate threshold for attention to the road given the context.
Great, thank you, Alex. And Stacy, I think you got locked out of your computer, so it looks like you're back now. Do you want to finish your thought there?
I did. Thank you for seamlessly cutting in there. Yeah, I was as actually what.
Oh no, it seems that maybe the talking is over the threshold of the computer here. So while we're waiting for Stacy to come back online, maybe Kevin, if you wanted to add any last minute points to this question.
Sure. So, from the human behavior, the standpoint, psychological standpoint, this is actually, the threshold of distraction this is not an engineering, not just an engineering problem. It involves the human behavior psychology, right? As Alex mentioned there. So we at Harman is doing a user study to try to understand this configuration and threshold. We have done a very diverse, geographically diverse North America, Europe, and Asia, and more than 5,000 objects or the participants were collecting systematic data to trying to determine okay, well, this is not only engineering problem, and this is a human behavior problem. There's other aspect in there. What are they? So we're trying to do this is where do we have the trigger? Exactly like what Alex said, at a different scenario, even different age group, different different gender, right? We have to personalize those things. And also, last point I want to make, hopefully that'll kind of contribute to the industry. Harman believes that we could develop jointly with the industry players a unified driving distraction score. Hopefully we can call it a driving performance score. Can be developed at a comprehensive measure of like visual distraction, mental modalities, drowsiness, and stress, and so on. So that can be a meaningful metrics to decide, okay, when to intervene, how to intervene, and we're developing, performing research and try to develop that.
So Stacy, I see that you're again back with us. I think we've resolved some of the technical issues. So please feel free to finish your thought on that last question.
Yeah, I was just kind of trying to wrap up some of the summary of one of our new research studies. Is really looking at how we keep drivers' attention toward the forward roadway. And when that visual attention goes away from the forward roadway, how do we effectively give alerts to people without inadvertently training them to keep their eyes off of the road? So making sure that we're not saying, okay, you can keep your eyes off the road for 2 seconds and now here's an alert. So really keeping that dynamic eyes on road task active, as well as what might be some effective modalities for keeping people engaged in the roadway. So how do we give positive reinforcement to drivers to keep their eyes on the roadway? As well as if we need to give an alert or warning, how do we issue that alert or warning? So a visual alert, for example, isn't going to be super effective if you're not looking in the direction of that visual icon. We also don't want to give people annoyance or nuisance alerts that are auditorily kind of disruptive perhaps to other people or annoying if they're not necessary. So kind of looking at those dynamics and really making sure that we can keep people on the road, but not annoyed with their vehicle systems.
Yeah, I think annoyance is a critical issue there. I completely think that the training aspect is critically important, and I think that goes beyond just distraction. That's for alerts generically as well. I wanted to, Stacy, get your thoughts here. Kevin mentioned considerations for age and gender and so forth when we talk about these sensors. I'm curious from the government's perspective, if there are demographic and or cultural considerations that we need to consider when automakers develop their systems, so that the holistic and diverse group of drivers is considered. Do you have thoughts on that?
Yeah, absolutely. So with any safety technology that we're putting into vehicles, we really want to make sure that we're designing that technology for everyone. And what's especially important is that we're not inadvertently excluding or biasing against one type or one group of person or people. So for example, if we're talking about things like PAEV, we want to make sure that those systems are recognizing all pedestrians on the roadway, independent of perhaps using a mobility device or their clothing or an atypical walking gait. So we, even in those sorts of things that are already on the roadway, we want to make sure we're inclusive of everybody. So when we're talking about moving into things like driver monitoring systems, especially camera-based driver monitoring systems, we want to make sure that we're designing these systems to be inclusive for everybody so they get the same safety benefit. So, you know, some of the things that continually come up are eye-opening aperture. So we want to make sure that we're able to detect all wide ranges of eye openings, things like strabismus. So when your eyes don't track at the same item at the same time, things like, you know, facial paralysis. Are you able to still detect gaze and expression, things like that, if your face isn't moving symmetrically? Even things that are starting to make their way, like odd reflectance of perhaps false eyelashes. We want to make sure that those infrared cameras are able to still capture eye movement there. And more odd things that are coming onto the market, like infrared blocking glasses. Like, are we accidentally pushing people into a direction to not use these systems? And then obviously, if we're moving into directions like non-infrared cameras, like a typical RGB camera, we know there are historical recognition issues for people of color or people with darker skin. How do we make sure that we're not introducing those same sort of biases into the vehicle if we start using those sorts of cameras for safety systems? And to that end, we actually do have a research project that is specifically looking at camera-based systems and different faces. So are there systematic differences in some of these systems that are already on the roadway? And if they do exist, where are those differences so we can help start addressing those potential systematic biases within the systems if they do exist?
Great. Thank you, Stacy. Alex, I would also love to get your thoughts on the same question.
Thanks, Mike. I would love to share my thoughts on that question. In addition to the list of individual differences that Stacy mentioned, I believe economic accessibility is an often forgotten issue when we're talking about technology solutions for these problems. And that's one of the things about dynamic function blocking that I think is really cool, because it's a scalable solution, which means that we can put the system on a range of vehicles, not just the premium brands that have a vast suite of sensors like the cameras and the radar and all those things. So what we're really looking to do is develop and implementing this affordable safety solution that will remove one significant barrier to broad deployment. Because as you know, the sensors add up. The cars are getting very expensive, and it's really important to us that we have a mass scale of these systems on the road that are affordable to all customers, not just the ones that can afford the really premium luxury vehicles. So.
Great. Thank you, Alex. And I think this lends itself well into this next question, which, you know, of course, this webinar is focused on in-vehicle technologies. But when we talk about distraction, we know it's not just focused on in-vehicles. I think there's been a lot of discussion from all of you about the context dependency, about various considerations for the drivers and for even really other road users. So let's pull back a little bit and look a little more high level from a safe system approach. And what I want to find out here is, in addition to some of the in-vehicle technologies, what are the considerations that we need to have from a safe system thinking, safe system mindset that can help us mitigate this distraction? And it's not just, of course, we're not taking the responsibility away from the vehicle, but we're looking at what other areas do we need to also consider in addition to the vehicle. So let me go ahead and start with Kevin on this question. Kevin, can you give us some thoughts from the safe system approach?
Right. So from system standpoint, our belief is that less is more, right? So decluttering keep a user concentrated, not distracted by our digital life, right? Cell phones, very fancy, getting bigger and bigger. The HMI screens in front of you, being the center stack or cluster. So simple, less is more, simple is more, and mind on the road. We have certain technology that we are developing in Harman International, that things like AR display, AR head-up display that can be used for combining with the camera. That when a user is detected as stressed or distracted, then we can intentionally to reduce the amount of the information put on the display or put on the HUD. So this is something Harman International believe this is the product we need for the industry.
Great, thank you, Kevin. Vishnu, do you want to add on to the safe system question?
Agree with what Kevin shared. I think it's also important to help drivers. So one way we are doing is how can we improve the overall attention of the driver in a non-intrusive way? I mean, telling the driver is not enough, but can we support him is also something that we are working on. We have something called microclimate, where we are able to adapt the conditions that the driver is in, which increases the overall attention. So that also helps in, let's say, distractions which are not planned distractions. So somebody not having a good sleep last night, etc., is also prone to distractions. So that's the direction we are supporting.
Great, thank you, Vishnu. Alex, same question. Safe system approach, what are your thoughts?
Yeah, so I want to first give kudos to NHTSA and the state and local agencies, and also the advocacy groups that have done a really great job generating the public awareness and consumer education piece about the dangers associated with distracted driving. I think this message needs to be continued to be shared broadly, because distracted driving is not socially acceptable, and continuing to do so puts your life and the lives of others at risk. I would really love to see distracted driving get the same treatment as driving while intoxicated or not wearing your seatbelt. And secondly, smartphones, as we know, are a major source of driver distraction. They're being brought into the vehicle. And I would want to continue to encourage drivers to use technologies that they do have available to them, even though they don't have a system built inside their vehicle to prevent this. But using do not disturb while driving mode on your devices is really a great way to curb the use of your social media or text messaging, all those things, to really focus on the road and keep your phone down while you're driving.
All great points. Thank you, Alex. And Stacy, why don't you wrap up this question and provide your thoughts on the safe system approach?
Yeah, absolutely. And I completely agree with the other things that have been mentioned. I think one of the great things that DOT as a whole is doing is really focusing on the National Roadway Safety Strategy, which integrates the safe system approach. So we've got a lot of efforts focusing on safer people. Safer vehicles, obviously, is one of my main focus areas. Safe speed, safe roads, and post-crash care. So really focusing on first responders and groups like that. We've got a lot of ad campaigns, buckle up, phone down, a lot of work on other crash avoidance systems. But I think one of the things you're really going to see moving forward, toward Alex's point, is really refocusing on distraction and driver attention, both from NHTSA and DOT as a whole. As you mentioned when we kicked this right off, the economic impacts of distracted driving are immense. And we're almost at 30% of all roadway fatalities as a result of distraction on the roadway. Those are alcohol numbers. We got to focus on getting people with having their attention on the roadway. And I really am excited to be able to continue to have conversations like these, work with advocacy groups, and really focus our research on changing the landscape and the policy out there, and getting us back to driving and advocating as individuals, tell your friends to get off the phone, don't take work calls while you're in the car, like those sorts of things I think end up going a really long way as individuals as well.
Yeah, I completely agree with everything that everyone has said. I mean, I just wanted to emphasize the collaborative nature of these discussions, but as we go forward into the research and the development of policy, I think collaboration is key here, because we all, as we've seen in answering all of these questions, we all have great viewpoints to add. We all have great perspectives on what technologies can be leveraged and how they can be leveraged. And we all have expertise in these various areas that can only be built upon through this collaborative effort. So I want to just, first of all, thank you all for your participation today. I want to give one last opportunity for each of you to just provide your final thoughts before we end here. And just take into account anything that has come up throughout this webinar that you think needs to either be reiterated, or if you have a new thought that you want to interject, this would be a great time. So let me kick things off first with Alex. Alex, if you have any thoughts that you wanted to add, we'd appreciate it.
Yeah, so my thoughts are, just again, don't drive while distracted. Use the technology that you have available to you. And I'm really looking forward to seeing all of the great research that's going to come out of NHTSA's renewed effort for distracted driving, and leveraging the findings from all of the great work they do to build better systems for our customers.
Thank you, Alex. Vishnu, do you want to add any last comments?
I see a huge synergy in the industry coming together to combine every bit of what we are doing. I see all of them as Lego bricks, and they're complementary, and they can actually be combined with each other to make a safe driving environment. So it's a call out to the industry to collaborate and make commute safe.
Yeah, thank you, Vishnu. I love the analogy to Lego bricks. That's a great one. Stacy, any last thoughts?
Yeah, I'm very excited for this renewed effort, as I mentioned. And put your phones down, keep your eyes on the road, and I can't go away without saying our doors and our inboxes are always open. We appreciate great ideas and potential ways to collaborate and work together. Obviously, anytime you see something in the Federal Register, we want those comments. We want your feedback. We want to know if we're headed in the right direction. My personal inbox is always open, so happy to hear where people are and hear great ideas. Thanks.
Great, thank you, Stacy. And Kevin, why don't you bring us on home here?
Thank you very much for organizing this, Mike and the team, and for every panelist. This has been a great discussion. I really enjoying it, and this prevent distracted driving is really in my heart, in our colleagues' heart, everybody's, right? So the distracted driving that include also the drowsiness, right? So Vishnu mentioned about pulling a coffee mug. We need to have something to need a technology to alert the driver. Okay, you are drowsy, right? Or you are distracted. Take some action, take a break, things like that. We cannot really ignore the drowsiness part. So yeah. So thank you again.
Great, thank you. And again, thanks to all of you. Not only do I appreciate your participation here in this webinar, I appreciate all the great work that you guys are doing in your respective companies. And I would say, keep it up. I think as we go forward, we're going to see great things. And I look forward to working with all of you to make those things happen. So thank you again for your participation. And everyone else, drive safe out there.
Thank you.
Thank you.
Thank you. Bye.
Thanks.